Hey everyone, since we are just about through with Chapter 6, we wanted to go take a run through of the big concepts we've covered so far and do some sample problems. So let's take a look here. So remember, an integral calculates the area between a curve and the x-axis. Now it's important to remember that areas that are above the x-axis are considered positive, and areas that are below the x-axis are negative. Now when we first started out, we started off by approximating these areas using LRAM, RRAM, and MRAM. So those are our rectangular approximations, rectangular approximations or Riemann sums, and then we also learned the trapezoidal rule. Okay, so then we learned that integrals could be calculated exactly using geometry formulas and antiderivatives. So like I said, we're just going to go through some sample problems for each of these. All right, so our first one says use LRAM, RRAM, MRAM, and trapezoidal rule to approximate the integral from 0 to 6 of x squared plus 2 dx with 3 subintervals. Okay, then we're going to talk about whether the estimate is an overestimate or an underestimate, and then we'll compare with the values on our calculator. So let's start with LRAM. So I know my interval is from 0 to 6, and we want 3 subintervals. So we know our delta x, or the base of our rectangle, is going to be 6 minus 0 over 3, or 2. So for LRAM, I have from 0 to 2, 2 to 4, and 4 to 6. And so I'm going to use my left endpoint. So at 0, my value is going to be 2. When it's 2, we're going to be 6. And then at 4 squared is 16, we're going to have 18. So my approximation using LRAM is going to be 2, because I have a common base of that rectangle. And then we're going to add those heights. So 2 plus 16, or 2 plus 6 plus 18, 26. So we get 52 for LRAM. Now, we know x squared plus 2 is going to look like this. So it's a parabola opening up, and it's x squared shifted up 2. So on the interval from 0 to 6, I have an increasing function. Again, I'm just focusing there because that's the region I'm integrating over. So if I'm integrating over an increasing function, or I'm using the left approximation, I know that 52 is going to be an underestimate This is going to be an underestimate because the function is increasing on this interval. And I'm specifying that it's increasing on this interval because we know that function is not increasing everywhere in its domain. Okay, so now our RAM we're going to do next. So I have my same intervals, 0 to 2, 2 to 4, and 4 to 6, and now I'm going to use the right hand. So at 2, we know that was 6, 4 is 18, and now 6, I'm going to have 6 squared 36 plus 2 is 38. So my approximation is 2 times 6 plus 18 plus 38. And so if I sum those up, I get 2 times, let's see, 62. Sorry, a little flow there. It's just going to give me an estimate of 124. Now, again, over that same interval, if I'm using right-hand approximations, that's going to give me an overestimate. And again, because of the same reason, because the function is increasing on this interval. All right, so last is our MRAM, and we know that it should be the average of these two values, but we're actually going to go through and calculate it to verify that that is the case. So now for MRAM, again, same intervals, but we're using the midpoint values. So now I'm going to evaluate the function at 1, so I'm going to get 3. At 3, we have 11, and then 5, we have 27. So now again, I still have a base of 2. I have 3 plus 11 plus 27. So 2 times, I have 41, which is 82. Let's see, did I do that right? Okay. MRAM, sorry guys, I misspoke in the video. I was getting ahead of myself with trapezoidal. MRAM is not the average. MRAM is just going to be, excuse me, in between LRAM and RRAM. Later when we get to trapezoidal, we'll check that that's actually the average of LRAM and RRAM. Don't mind me. Okay, so that's 82. So now let's go ahead and do our trapezoidal estimate. And again, trapezoidal, we know, should be the average of LRAM and RRAM. But we're going to actually compute the trapezoidal and not just average those out. So we have our intervals from 0 to 2, 2 to 4, and 4 to 6. And again, with trapezoidal, we're using both endpoints. So we can fill those in. 0 was 2. 2 had a value of 6. 4 is 18. And then 6 was 38. So now we have to be careful when we're doing trapezoidal. We know the area of a trapezoid is h over 2 times b1 plus b2. So in our case, our height is 2. So when we find the area, we have 2 over 2, or just 1, and then we're adding up the y values. So I'm actually say 2 plus 2 times 6 plus 2 times 18 plus 38. And I'm going to jump to my calculator quickly to evaluate that. So 2 plus 12 plus 36 plus 38 is going to be 88 for our trapezoidal approximation. And again, we expected that would be the average of LRAM and MRAM. So if I do 52 plus 124 and divide it by 2, we do get 88. So we know that's correct. Now, in terms of whether we have an over and under estimate, we said that for trapezoidal rule, this depended on the concavity of the function. So our function is concave up. So for trapezoidal rule, if I do trapezoids with a concave up function, I'm going to get an overestimate. So I'm going to say this is an overestimate because the function is concave up. All right, so there's our quick review of our approximations. So now we're going to move on and look at computing integrals with geometry formulas. All right, so here's my first function, and I want to integrate from 0 to 6. So this one's pretty nice and easy. I do have to be a little careful here. From 0 to 1, I notice that I have some negative area, so I have to make sure I count that as such. So I'm going to have a negative, that's triangle. So I have 1/2 times 1 times 1. And then I have my positive area here. And that looks like a trapezoid, so we'll use our trapezoidal area. So the height of that trapezoid is 2. So I have 2 over 2. My base 1 here is 1 unit long, plus my base here is going to be 5 units long. So now if I simplify, I have negative 1/2, let's see, plus 6. So I'm going to get an area of 11 over 2. So again, my integral is positive because I have more positive area than negative area over that interval. Okay, so the next one, I'm integrating from -4 to +4. So I have a couple things to be aware of here. So I have all this area in blue is going to be negative area. I have my semicircle region here. And then I'll have positive area from 2 to 4, so a triangular region of positive area. So let's see, let's do our negative first. So I have -1/2 times the base, looks like 2. The height of that triangle is 1. Minus, I know I'm going to have a semicircle, so pi, the radius is 2. Pi r squared over 2 because it's a semicircle. And then I'm going to add my triangular region 1/2. The base is base length 2. And the height is also 2. So let's see what I have here. I have -1 minus 2 pi, and then let's see, plus 2. So my net area here is going to be -1 plus 2 is 1 minus 2 pi. All right, next piece is just going through doing some antiderivatives here, so calculating them exactly. So this one is just going to be our power formula. I know if I have any kind of polynomial here, I'm just going to add 1 to the exponent, so it's going to be x to the 4th, and then I'm going to divide by that new exponent, and I'm evaluating from -1 to 2. So now I'm going to have 2 to the 4th over 4, minus a -1 to the 4th over 4. So 16/4 minus -1 to the 4th is going to be positive, so -1/4 is going to be 15/4. And again, I can calculate that, check that using my calculator. So math 9, -1 to 2 of x cubed dx, 3.75, which matches our answer. So again, we need to know how to do these by hand, but I would always recommend if you're doing it in the homework, checking it with your calculator. My next one, I have e to the x here, and remember using our properties, this is just the same as 3 times the integral from 0 to 3 of e to the x dx. So I have 3 times my antiderivative of e to the x is just e to the x, and I'm evaluating from 0 to 3. So I have 3 times e to the 3rd minus e to the 0. So I have 3e cubed. E to the 0 is 1, so 3e cubed minus 3. Okay, next one, antiderivative of cosine, I know is going to be sine. So I have -pi/2 to pi/2. Oops, why am I writing the integral again? Sorry, guys. My antiderivative is sine, so I have sine of x, and I'm evaluating from -pi/2 to pi/2. So now I have sine of pi/2 minus sine of -pi/2. So sine of pi/2 is 1, minus sine of -pi/2 is a -1, so that's going to give me a value of 2. All right, and last but not least, the integral from 3 to 6 of 1 over x dx. Again, this is the one we said we had to be really careful of, and whenever we see 1 over x, we know our antiderivative is the natural log of x, and I'm evaluating from 3 to 6. So that's going to be the natural log of 6 minus the natural log of 3. Now, if this were a calculator question, we could approximate that by entering it into our calculator, or we can just leave it exact. All right, one more example, and then we are done with videos for this chapter. So, total area. Remember we said to find the total area, we need to add up all the absolute values of these areas. So the first thing I need to do is I need to take my curve, sine of x, and I need to find its zeros. So I'm going to find out where sine of x equals 0 over the interval from 0 to 2 pi. So I know that's going to happen at 0, at pi, and at 2 pi. So I'm going to have to break this up into two intervals here. I'm going to have the integral from 0 to pi of sine of x dx, and we're going to have the integral from from pi to 2 pi of sine of x dx. Now, when we take the antiderivative, we have to remember that its antiderivative is negative cosine of x. And we're doing this from 0 to pi. So I have opposite of the cosine of pi minus opposite cosine of 0. Cosine of pi is negative 1, but I'm taking the opposite, so that's going to be 1 minus cosine of 0 is 1, but I have the opposite, so minus a negative 1, or 1 plus 1 is going to give me 2. So I know I'm above the x-axis from 0 to pi. Now, from pi to 2 pi, I have negative cosine of x from pi to 2 pi. So the opposite cosine of 2 pi minus the opposite cosine of pi. So now again, cosine of 2 pi is 1, taking the opposite, so negative 1, minus cosine of pi is negative 1. I'm taking the opposite, so it's going to be 1. So this is negative 2. So now to find the total area, I'm going to take 2 plus the absolute value of negative 2, and we get a total area of 4.